Good morning, friends. Today we are going to learn square potential barrier. Previously, we have learned square well potential with infinite volts and finite volts. So, with after analyzing those two examples, we have also analyzed a free particle, square well potential with infinite volts or a particle in a box, square well potential with the finite volts. So these are the one-dimensional examples we have analyzed. Now we know how we are dealing with a quantum mechanical system. First of all, we take the Schrodinger equation, then apply the potential defined for the system, then we try to solve it. So here we have square potential barrier. I'll show you the figure. Yeah. So this is the square potential barrier. So in the previous case, we had a square well potential with finite volts. So this is just the reverse of the case. So here we have three regions. Region 1, the importance of region 1 is that region 1 is having potential 0. So we have taken the dimension in the x direction, that is the barrier exists from 0 to a. So we have barrier in region 2. Okay, region 1 and region 3 do not have any potential. So we can call V is equal to 0. But in region 2 we have a barrier of V0. So that is what we have defined here. For x less than 0 we have a V of x is equal to 0. And for 0 less than x less than a we have V0. And for x greater than 0, again we have potential 0. So now we are going to consider a stream of particles of mass m approaching the square barrier from the left, that means from the region 1. A stream of particles entering towards the region 2 from region 1. Okay, so we have two cases as we have done previously. The possibility that energy of the particle can be less than V0 or greater than V0. So what is the chance of getting transmitted to the other region? So if we say that the particle is having energy less than V0. So classically there is no possibility to get transmitted to the region 3 by penetrating through region 2. But if E greater than V0, we can say that it has sufficient energy and it gets transmitted to the region 3. But what we are going to prove is that while we analyze the probability or the coefficients of various coefficients in region 2, that is the transmission and reflection coefficients, what we understand is that quantum mechanically there is a chance, or we call it a finite probability, for a particle to penetrate or leak through the barrier and continue its forward motion even if E is less than V0. And we call this phenomenon quantum mechanical tunneling. And it is possible because of the wave nature of the matter. Okay, so these are the things we have to analyze. So first of all, we have to write Schrodinger equation in all the three regions for the case E less than V0, and then we will go for E greater than V0. So these are the Schrodinger equations for E less than V0. For E less than V0, this is just like the Schrodinger equation in the case of V equal to 0 region. Okay, so this is the case of a V is equal to 0 region, this one and this one. 4.27 and 4.29. Because you know that potential is 0 and we will have only the coefficient k square here. So if you want, I will write it. Yeah. So our general equation, Schrodinger equation is d square psi by dx square minus h cut square by 2m d square psi by dx square plus v of x into psi is equal to e psi of x. Okay, psi of x, because we are dealing with one dimension. Okay, so this is our time independent Schrodinger equation. So we have to give the value v of x is equal to 0 for the region. You know that we are taking region 1 where we have v0 is equal to 0. Okay, so let us write the wave function in region 1 as psi1. So minus h cut square by 2m d square psi1 by dx square is equal to e psi of x. Okay, so we have to rearrange it. Rearranging it, you take minus h cut square by 2m to the left hand side, I mean right hand side. So we have d square psi1 by dx square is equal to minus 2me by h cut square into psi of x. Take both the the term on the right hand side to the left hand side, and we will write it as a okay. We'll take this term to the left hand side. So we will have d square psi1 by dx square plus 2me by h cut square. Sorry, here also I am supposed to write psi1. Okay, psi1 of x is equal to 0. So this is the case of Schrodinger equation in region 1. Similarly, in region 3, you will have psi3, and the equation will be d square psi3 by dx square plus 2me by h cut square psi3 is equal to 0. Only in region 2 you will have a potential. So in region 2 you can write, yeah, I think region 2 you have to use this equation, and we should give v of x as v0. Okay, so region 3, I mean 2, minus h cut square by 2m d square, remember we have psi 2 by dx square plus v0 psi is equal to psi 2 so rearranging it you will have let us do one thing. Minus h cut square by 2m is 2m by minus 2m by h cut square is multiplied throughout, so that we will have d square psi 2 by dx square minus 2m v0 by h cut square psi 2 is equal to 2m minus 2m e by h cut square psi 2. Take this one to the left hand side, so d square psi 2 by dx square, take minus outside, and when this term comes to the left hand side it will be positive. So when I take minus, okay, I'll write it once more, 2m v0 by h cut square psi 2 plus 2m e by h cut square psi 2 is equal to 0. Okay, so d square d square psi 2 by dx square minus, you take minus outside, so 2m is also 2m by h cut square can also be taken outside, so 2m by h cut square into v0 minus e into psi 2 is equal to 0. Okay, so this is the Schrodinger equation in region 2. So if we give this term as alpha square, you will get the other equation which was given in, I'll show you. Now we have attained these three equations. So this is the case of region 1 where we have given 2me by h cut square as k square, so you have this equation, and in region 2 you have alpha square, and in region 3 also similar, the case is same as region 1. Now we have to give the possible solutions, because we know what is happening. A stream of particles are coming from the left hand side, that is from region 1, and there is a possibility of the incident wave to get reflected. So there is a possibility of incident wave as well as reflected wave in region 1, but in region 2 there is a chance of exponential growth or decay. Suppose if the particle is getting transmitted, so there will be a chance of an exponential increase first, and then there may be a decrease. And in region 3 we will have only transmitted waves. Okay, so accordingly we will assume the solutions. The solutions are taken as psi1 is equal to e raised to I kx plus a e raised to minus ikx. So the amplitude of incident wave is taken as 1, and the reflected amplitude, we are not sure about the reflected amplitude. If we are, once we are able to calculate the reflected amplitude, we can say that the reflection coefficient in region 1 is a mod a square. That is actually the probability. If you remember, we had probability amplitudes as a coefficients. I'll write it. Okay. Um, we used to write a random wave function psi I in terms of orthonormal basis vectors. If you remember, this is called the expansion theorem. The phi i's are orthonormal basis vectors, and the random vectors for that system is written as a linear combination of the orthonormal basis vectors. So if it is so, if we want to calculate Ci, we have to left multiply phi I. Phi I psi I is equal to Ci, sorry, Ci phi I phi I. So this is delta II, this is equal to 1, so it is Ci. So the coefficient Ci actually represents a probability amplitude phi I psi I. So this is a probability amplitude of the system being in psi I. So similarly, the coefficient in our equation, plays the role of the probability amplitudes. So the mode square of the coefficient will give the actual probability. So mode A square gives the reflection coefficient here. And mode D square gives the transmission coefficient. Okay. So let us evaluate the coefficients. For that, what we are going to do is we are going to apply the continuity equations. Like what we have done in the case of a square well potential well, square potential well. So let us consider the boundary x is equal to 0. So at x equal to 0, at x equal to 0, psi 1 at x equal to 0 will be equal to psi 2 at x equal to 0, right? Similarly, the second continuity equation is that psi 2 at x equal to a will be equal to psi 3 at x equal to a. So these are the continuity equations of the wave functions in various regions. So we are going to consider the continuity equations at a boundary x equal to 0 and x equal to a, and by rearranging and modifying the equations, we'll get a number of mathematical equations, and by modifying them or using them, we will be able to calculate the reflection and transmission coefficients. So first of all, let us apply the continuity equation at x equal to 0. So when we apply the continuity equation of the wave function and their first derivative are taken. Okay, let us write that. First at x equal to 0, continuity equations of psi and d psi by dx at x equal to 0. That is what we are going to analyze first. Okay. So our wave function psi 1 is let me write wave functions once so that you won't be in confusion. Psi 1 is equal to e raised to ikx plus a e raised to minus ikx psi 2 is equal to b e raised to alpha x plus c e raised to minus alpha x. So these are the two wave functions we require at x equal to 0. Okay, so let us apply it. So okay, at x equal to 0, psi 1 becomes psi 1 at x equal to 0 implies e raised to I k0, that means e raised to 0, which is 1 plus again a into e raised to minus I k into 0, that is also 1. So this becomes 1 plus a, that is psi 1, then that should be equal to psi 2. So b into again e raised to 0 1 plus c into e raised to 0. So this is the first equation. Let us call it equation yeah, I think we will write the same as given in textbook. It is 4.33a. Okay, 4.33a. 4.33a. Now, first derivative d, yeah, this is equal to psi 2 at x equal to 0. Okay, again d psi 1 by dx at x equal to 0 is equal to d psi 2 by dx at x equal to 0. Okay, that implies, first let us take the derivative, that is I k e raised to ikx plus a minus ik e raised to minus ikx is equal to, now we have to apply x equal to 0 condition. X equal to 0, that is equal to derivative of psi 2 is b alpha e raised to alpha x plus c minus alpha e raised to minus alpha x at x equal to 0. Okay. So applying x equal to 0, you will have ik into e raised to ik0 is 0, I mean e raised to 0 1, so plus, no, not plus, it is minus a ik again e raised to 0 1 is equal to b alpha e raised to 0 1 minus c alpha e raised to 0 1. So this is going to be the second equation. So we will call it 4.33b. Okay, we have 4.33a and 4.33b. Now the next task is find continuity at x equal to a. So these are the equations where we get when we apply continuity equation at x equal to 0. Continuity of psi at x equal to a. So before that we have to write the wave functions. Wave function psi 2 is equal to b e raised to alpha x plus c e raised to minus alpha x. and psi 3 is equal to d e raised to I kx. So first of all, psi 2 at x equal to a is equal to psi 3 at x equal to a, and also d psi 2 by dx at x equal to a is equal to d psi 3 by dx at x equal to a. Okay, first one apply x equal to a. So we have b e raised to alpha a plus c e raised to minus alpha a is equal to d e raised to I k a. Let us call it equation. Yeah, I think we have to give the same equation number so that we may not be confused. So the equation is 4.34a. 4.34a. Okay. Now, this case, take the derivative. So b alpha e raised to alpha x plus c minus alpha e raised to minus alpha x at x equal to a is equal to d I k e raised to I k x at x equal to a. So our equation is b alpha e raised to alpha a plus minus c alpha e raised to minus alpha a is equal to d I k e raised to I k a. 4.34b. So these are the equations we have. I'll take this one. Now we have 4 equations. Now we are going to solve these 4 equations and try to find out the value of d and the reflection coefficient mod a, and the mod a square gives reflection coefficient. Okay. Or in another way we can do find one of the coefficient, either transmission or reflection coefficient, and find the subtract this one from unity, because we know that reflection r plus t is equal to 1. The total probability will be 1. So here what we have done is d represent the transmission probability amplitude, and we find d first and then take r from t as 1 minus t. Okay, so let us analyze it. So we begin with equation 4.34a and b. Okay, 4.34a, take 4.34a and divide it with e raised to alpha a. Okay, divide it with the e raised to alpha a, so it becomes b e raised to alpha a plus, divide it with e raised to alpha a plus c e raised to minus alpha a divided by e raised to alpha a is equal to d e raised to I k a. divided by e raised to alpha a. So we have a b plus c e raised to this alpha a comes up. This one actually got cancelled. This alpha a and this alpha a got cancelled. This one comes up. So we have 2 alpha a and this one also comes up. So e raised to minus 2 alpha a is equal to d e raised to ika minus alpha a. This is next equation. We'll just call it 4 point, yeah, I am going to just call it a 4a. Okay, because in the textbook after a few calculations the number is given, so I'm going to call it 4a. Okay, then now the second equation, 4.34b, take this one and divide it by alpha e raised to alpha a. Okay, so we have a, I think I'll use another color only to understand this one. This one is going to be rewritten by dividing throughout by alpha e raised to alpha a. So b alpha e raised to alpha a divided by alpha e raised to alpha a minus c alpha e raised to minus alpha a divided by alpha e raised to alpha a is equal to dik e raised to ika divided by alpha e raised to alpha a. This becomes b minus, again here alpha e raised to alpha a will be cancelled. This much will be cancelled. Here also alpha will be cancelled. This comes up. And this term e raised to alpha a comes up. Okay. So the equation becomes b minus c e raised to minus 2 alpha a is equal to ik by alpha e raised to ika minus alpha a. So I am going to call this 4b. Okay. Now we have a okay, let us call this with another number. That is only for sorry. So I'm going to call this 5 because we already have given different numbers using 4 point, all those things. Okay, let me call this one 5a. Okay, 5a and 5b. Okay, so these are the new equations. So adding 5a and 5b, let us add these two. So yeah, you have b plus c e raised to minus 2 alpha a plus b minus c e raised to minus 2 alpha a is equal to d e raised to ika minus alpha a plus ik, yeah, d, I think I left d here, d ik d e raised to ika minus alpha a by alpha. Okay, so just take this term get cancelled. C plus c e raised to minus 2 alpha a and minus c e raised to minus 2 alpha a get cancelled. So you have 2b is equal to, take d e raised to ika minus alpha a outside, so you have a 1 plus ik by alpha. Take LCM, that is alpha plus ik divided by alpha into the common term d e raised to ika minus alpha a. Okay, now just let us just rearrange it. B is equal to, take a 2 to the right hand side, B is equal to d by 2 alpha into alpha plus ik, alpha plus ik into e raised to ika minus alpha a. So let us call this equation 6a. Now let us subtract 5a and 5b. Okay, here we have added, and now we are going to subtract it. So just b plus c e raised to, c e raised to minus 2 alpha a minus b plus c e raised to minus 2 alpha a is equal to d e raised to ika minus alpha a minus ik d by alpha e raised to ika minus alpha a. Okay, so what happens to these two terms? B is cancelled, b and minus b. So you have c, 2 times c e raised to minus 2 alpha a. Okay, and the right hand side becomes, again you can take a d e raised to ika minus alpha a outside. So what you have is 1 minus ik by alpha. Take LCM, so it will be alpha minus ik by alpha d e raised to ika minus alpha a. Okay, and now we can take minus 2 e raised to minus 2 alpha a and 2 to the right hand side. So c is equal to d by 2 alpha minus ik, then the exponential e raised to ika minus alpha a divided by e raised to minus 2 alpha a. Okay, so here you have 1 e raised to minus alpha a, and here you have 2 e raised to minus 2 alpha a. So one of them get cancelled. So what you have is, so you can rewrite it. C is equal to d by 2 alpha minus ik into e raised to ika plus alpha a, because one of them get cancelled. Okay, so let us call this one 6b. Now you have 6a and 6b. Now apply these values in the first equations, that is 1 plus a, the equation we got by applying first boundary condition at x equal to 0 and its derivative. Okay, so I'll just rewrite those equations. Yeah, these are the equations. 1 plus a is equal to b plus c, and ik minus a ik is equal to b alpha minus c alpha. Okay, so we are going to substitute our b and c here. So I'll use a different color. Okay, so our equation is 1 plus a is equal to b plus c. So you know that b is I'll just show the equation. So yeah, this is b. See, you can see b and c here. So it becomes d by 2 alpha plus ik e raised to ika minus alpha a plus c is d by 2 alpha minus ik e raised to ika plus alpha a. Let us rearrange it. Okay, so if you multiply alpha throughout and rearrange it, you will get alpha into 1 plus a is equal to here you will have alpha into d by 2 alpha plus ik e raised to ika minus alpha a plus again alpha d by 2 alpha minus ik e raised to ika plus alpha a. Okay, these alphas get cancelled here also. So what you have is d by 2 alpha plus ik e raised to ika minus alpha a plus d by 2. If you want, d by 2 can be taken common, so I'm just going to write it like this: alpha minus ik e raised to ika plus alpha a. So I'm going to name it 7a. Okay, now in the derivative part, that is the equation ik minus ika is equal to alpha b minus alpha c. Again we are going to write substitute b and c in this equation. If you remember, these two are the equations. This equation we got by applying the continuity equation at x equal to 0, and this is the same case with the differential at x equal to 0. I'm repeating it once more. Psi 1 at x equal to 0 is equal to psi 2 at x equal to 0. is this equation, and this is d psi by dx at x equal to 0 is equal to sorry, d psi 1 by dx is at x equal to 0 is equal to d psi 2 by dx at x equal to 0. So we have substituted b and c already in this equation, and we have 7a. Now we will again substitute b and c here as well, and we will obtain 7b. Okay. Okay, so it is alpha, sorry, this is equal to alpha into b is d by 2 alpha plus ik e raised to ika minus alpha a minus alpha into c is d by 2 alpha minus ik e raised to ika plus alpha a. Okay. Now